When we solve a system of equations, there are different methods that we can use. Now remember, when we talk about a system of equations, we are talking about multiple equations and multiple variables. Right now, we're working with two equations and two variables. And we can solve a system in this form by graphing, which means we can write equations in slope-intercept form and plot them on a graph. But the second method that we're going to talk about next is called substitution. There is a third method that we'll also look at coming soon, and that's elimination. But let's focus on this idea of substitution for just a moment. Let's say that we know A is equal to 7. And we also know that 5a is equal to b. Well, because a equals 7, we can take this known fact and put 7 in for a. Therefore, we would end up with 5 times 7 equals b, and b equals 35. This is what substitution looks like in algebra. And it's also what it looks like as a method to solve a system of equations. So let's get into that. Let's say we have a system of equations and we have a 5x plus 2y, and that equation is equal to 53. We also have x is equal to y plus 5. Okay. So what we notice here is that we know what x is. X is equal to y plus 5. So what we're going to do is we're going to take this y plus 5 right here, and we're going to put it in for x in the other equation. So when I do that, I'm going to keep my 5 from the original, but instead of x, I'm going to write in parentheses y plus 5. Now the remainder of the equation, plus 2y, equals 53, goes on the end. Now to solve this, I'm going to go ahead and distribute through. Now notice what's happened here. We have an equation that has all y's in it. So this is now 5y plus 25 plus 2y is equal to 53. I'll simplify the left side, so 5y plus 2y is 7y plus 25 equals 53. I'm almost there. I'm going to subtract 25 from both sides. 7y then is equal to 53 minus 25, that's 28. We'll divide by 7, y is equal to 4. Hooray, I'm done. No, I'm not done. Because when I solve a system of equations, what I'm looking for is I'm looking for an ordered pair, or some cases ordered pairs, that solve the system. So if I have y equals 4, I'm going to take y equals 4, and I'm going to plug it back in to this second equation. So that leads us into x equals y, which is now 4, a known quantity, plus 5, and so x is equal to 9. Hooray! My final answer is 9, 4. Now, if I plug that into both equations, it should work. Well, we already put the 4 into the second equation. 4 plus 5 is 9, but does it work in the top equation? Well, when I put that in, I would have 5 times x plus 2 times y. Does that equal, not 23, but 53? Well, 45 plus 8 is equal to 53, and that is a true statement. So, we are correct. 9, 4 is the solution to the system. In this system, y equals negative 2x plus 8 is going to be our first equation. Our second equation is going to be y equals 3x plus 13. Well, Think about this for just a moment. Over off the side, if m is equal to 4 and n is equal to 4, well, they're both equal to 4, so that means that m is equal to n, right? They have to be. So in a situation like this, since they're both equal to y, we're going to make a substitution. We can do it a couple of different ways. One way is I can take 3x plus 13, which is the same as y, and I can put it into the first equation. But I could also take the negative 2x plus 8 and put it in for y in the second equation. Either way I do it, we're going to end up with the same thing. So let's do it how I have it drawn out. So 3x plus 13 is going to equal negative 2x plus 8. Now to solve it, I'll go ahead and get the variables on one side. So I have 5x plus 13 is equal to 8. And next I'll subtract 13 from both sides. So 5x is equal to negative 5. And solving for x gives us an x equals negative 1. Once again, I'm not done. I'm halfway there. So I can take this negative 5, and I can go ahead and put it, or this negative 1, excuse me, and I can put it back into really either equation. So doing that gives us y equals 3 times negative 1 plus 13. So y equals negative 3 plus 13, or 10. And I have my ordered pair. My ordered pair that we would have for this particular one then would be negative 1, comma 10. Now, both of these examples were nice because we had x equals or y equals, and that's a good strategy when solving a system as well. But this last system I want to look at, 5x minus 2y equals negative 5 for the first equation. And the second equation, negative 2x plus y is equal to 4. Well, I don't have x equals or y equals. But could I make it so I did have x equals or y equals? Well, we're going to try that. So I can't solve for x here. Well, I could. It would just be a little complicated. Don't really want to solve for y here, same reason. Don't really want to solve for x there. So I think I'm going to go ahead and solve for this y right here and try to get y by itself. Now, again, I could try to graph both of these, but it could get very, very complicated in doing so. So let's go ahead and do this. Let's take this second equation right here. And let's go ahead and get this y by itself. Now to do that, all I need to do is add the 2x over to both sides. And so I get this new equation that we'll put in green here. That's going to be y equals 2x plus 4. Okay. So I'm really dealing with this equation, this new version, and I'm dealing with the first equation. Now, I can't put this new equation back in itself. So the next thing I'm going to do is I'm going to take this first equation, and I'm going to have 5x minus 2. Where I see the y, I'm going to put 2x plus 4. And that's equal to negative 5. Now take a moment and actually pause the video and see if you can finish it from there. And I'll be back in a moment and show you how it all plays out. So again, pause if you would at this time. So let's see what you've done and see if we align. So first line, second line, x turns out to be 3. Halfway done, I'm going to take this 3 and I'm going to put it into the easiest place where I could find y, which is going to be in this greenish equation. So y equals 2 times 3 plus 4. And if you're sitting there with an answer of 3, 10, congratulations, you've done it. It's not the world's best cup of coffee, but it is the solution to the system. This is how you solve a system by substitution. Next to come, elimination. And with graphing, substitution, and elimination, you will have all the methods to solve linear systems.